As promised, another brief lecture. This time we're going to be talking about types of program. There's 4 basic types of program that are written for computers. The first is the type that you basically learn in CS 1 and 2. It basically runs once. There's a start, runs through, maybe does a little bit of jumping around on subroutines, and then it ends. This is the type of program that you would have for a utility, something that you run once or twice to accomplish some goal, like installing a program or processing a picture just once. It runs once, has a definite start and a definite end. And that's all there is to it. Like I said, this is the type of program that you learn about in CSS, or CS 1 and 2. The second type is the start loop type of program. It typically has 2 functions, a start function and a loop function. The start function runs once at the beginning when you first start the program, and then the loop runs endlessly. It doesn't have a end to it. If you've ever programmed on Arduino, you'll be familiar with the start loop type of program. So has a start function, that runs once, once, just and then a loop, loop function runs endlessly. A lot of embedded systems use that type of structure. It runs until you cut the power. Like I said, you'll learn about that in embedded systems. Or if you ever want to work on the side outside of class with Arduino, with the Arduino environment, the start loop function is used by that. The third type of program, event driven. It has a start and goes to a event loop that runs until the program is over, and it just waits for events in the event loop. Now, what is an event? Typically, an event is a user input of some variety. In Java and C# and various other programming languages, things like clicking a mouse, double click, right click, hitting the space bar. So it just sits and waits and does nothing really until something like this happens, some event occurs. And then it jumps out to the event handling routine. And then goes back to the event loop. So you can see it's basically a derivative of the start loop type of program. But all the functionality is really in the event handler routines, the various routines and that are written for each mouse click or double click or pressing a button on the screen. That would be a event. And there's most programming languages recognize dozens, if not hundreds, of events, like moving a mouse over a button on the screen, moving the cursor over the button on the screen. There's an event for that. So, like if you go when you, and for example, in a web browser, you bring the cursor over a hyperlink, the cursor changes. That's responding to the event mouse over a particular item on the screen. For a click, there's button down, click, and button up. 3 different events. So pushing the button triggers an event. Having it being held down triggers another event. And then releasing the button triggers yet a 3rd event. So a lot of functionality can be programmed into these event handler routines. Very similar to the event-driven program is the interrupt-driven program. Again, they typically have a start phase and then go to a event loop. Sometimes the event loop does nothing. Sometimes it does some rudimentary processing. But it waits for the triggering of interrupts, which are hardware generated. So it waits for interrupts. Such as a timer, a analog to digital conversion. But these are all internal within the processor. So they interrupt they need to be handled in a timely fashion. So they interrupt the processing in the main loop and take care of their processing that they need to do. So they jump out to interrupt service routines. Or ISRs. They jump out and then go back when they are done, resuming what was going on prior to the interrupt. Interrupt programming is usually done very close to the hardware level. In comp.org, you should learn about that, computer organization, how to handle interrupts in assembly language at the low level in the AVR environment. Usually programs, a lot of programs are a combination of event and interrupt driven. They take input from the user and use that to affect the interrupts, the interrupt handling of the program. A operating system is a good example of that. It deals with the hardware. Operating systems act as a go-between between the hardware and the user. So they deal with the hardware interrupts, like when a disk read is made and the data is available, that triggers an interrupt. That the data is now available from the hard drive to the user. It can be displayed or used however the program running wants it to be handled, while at the same time handling the events that are generated by the user. So an operating system is kind of a hybrid between interrupt and event driven. But just sitting there, it does nothing. It just sits in there in the main loop, spinning its wheels, maybe keeping track of the time on the screen. Other than that, it's not doing anything. If you look at what's that program that you use to look at the processor activity? Task Manager. Thank you. If you're just sitting there, the Task Manager, the CPU's usage is down low, close to 0%, and nothing's going on. Whereas with disk accesses, network accesses, that sort of thing, processor activity goes up from interrupts, even though you may not be doing anything, clicking any buttons or anything like that. If in the background, hardware functions are causing various types of interrupt. And then your button clicks, your typing on the keyboard are events that trigger behavior as well. But yeah, so there's basically 4 types of program. You can mix and match and have hybrid versions, hybrid programs. But when you go to write a program, you should really look at what's going on. How should this be written? Is it interrupt driven, or is it event driven? Is it like an alarm clock that just trigger, with a simple interrupt for time from timers, or any of a variety of different types of program. But yeah, those are the 4 types. Like I said, the closing weeks are going to be brief lectures. Next time we're going to discuss where to go for information. Who can you trust out there in the world of misinformation and the less than reliable internet? But in the meantime, have a good weekend. Study hard for your finals. Get the spring registration taken care of. And have a good day.